Today, the laundries are facing a common challenge, and that is shortage of labor. The cost of labor has been a challenge for a very long time, and Spindle's been a key driver at addressing that. Still a lot of humans that are required to do things like feed a towel into an ironer, or feed napkins into an ironer, or hang shirts and pants on a hanger. And there's more out there that has been very difficult to solve in an automated way. So as we looked around at the different tasks, and we, like I said, through the lens of how do we grab a count, now we started to look at it from a perspective of what still has not been automated in commercial laundries, and why has it not been automated?
So it depends entirely on the task. Mm-hmm. So even with the first set of data collection, right? So what we pretty much do is a dexterity map. So we take like the variations that can be done and the difficulty with which it can be done, right? So even like opening a bottle, right? Like all of us would do it different ways. So the data collection process involves collecting all these methods. And what we try to do is the simplest way it can be done, and it suits the gripper. And then if that's the best part, and it's doable, we just stick with that. Whereas if a task is complex and the variability is very high, then we might also need to do for the data collection and for the feedback. So it's entirely dependent on the task. So, but if it is reliable from the first thing, we probably wouldn't need much more data.
Yeah, I mean, we think, I don't know what you guys think, that this is a complex, highly variable task, taking a napkin and feeding it. That's our impression. But
yes, it is. Okay. Yeah, we're discussing this morning.
And that's why I asked the question. So now we don't have...
Here is like these grippers. So they are the ones that will go onto the arms later. So instead of collecting it with hands or like a different gripper, we collect with the same gripper. So these basically you can control the fingers using the joysticks button here. And I can start and stop the recording from here as well. I can start recording and then stop recording from this button here. So what we do is we track these markers. They represent an object. So these set of markers here on the left and the right, they are different.
When we first got into robotics, the first thing we did is myself and a couple other key team members went to the big robotic shows. Automate's one of them. And we spent 4 or 5 days at the convention center floors just walking as many booths as we could, taking prolific notes, having long conversations with many of the providers, both from the robotic arm providers to the computer vision providers to the software providers. We did a lot of research, and it became evident very quickly, and not that we didn't think this would be the case, but we were going to have to find the right partner.
When you transfer to the robot, the sliding may be different, so you see that the lamp moves more. Or here, on the other direction, it moves much more.
My name is Minas Yarogapis, and I am the CEO of Acumino. Acumino develops AI models for robotic systems that can be as dexterous as humans. Robotic systems that can be useful in production today. Another unique challenge that we are facing with Acumino is the manipulation of deformable objects. And deformable objects are particularly hard because you can see how they deform out of the plane, how they deform under the contact forces, and how the shape that they take is very unpredictable. All these dynamic phenomena that are hard to manipulate, we encapsulate them in the data, and we use them in order to train the most accurate AI models of physical interactions.